Advanced Financial Modeling, Topic 8, Python for Finance, Learning Objective number 4. We're going to run a Monte Carlo simulation in Python. So what I'm going to do is I'm going to take this spreadsheet here, which runs a simulation of the value of a portfolio 20 years from now. I'll show you the macro simulation I ran and some of the expected or some of the results. And then what we're going to do is show you a program that replicates this in Python. And then you're going to modify this program for the assignment. So let's first take a look at the spreadsheet. So the spreadsheet has parameters: present value of a portfolio, $1,000. The mean is 8% return. That's mean return. Volatility, 20%. Payment, $5,000. That's the first payment. Payment growth, 2%. And it's going to be 2 years. So the portfolio starts at $1,000. That $1,000 grows at 8%. And then we're going to take the payment times 1 plus the payment growth times the I minus 1, because I want to skip this the first growth factor. So I want to take this to the 0 power to make the first payment 5,000. And then I just copy down. So what you see is the end of the 20th year, you should expect 269,245. We'll call that the expected value. And then I'm going to run a simulation using the random walk model. Same formula, except it's 1 plus the mean plus norm S inverse ran times the vol. Same formula though. Then what I did is I ran a macro, and every time I hit, well, let me show you here, every time I hit F9, I get a different portfolio value in row 29, column C. I then copied that 10,000 times over here, and the average is 267, pretty close to the expected value. There are 10,000 iterations. If I count them, the probability or the numbers greater than, say, 400,000 is 15%, is the amount of numbers greater than 400,000. The 10% smallest number in that array is 119,000. The 10% largest number in that array is 461,000. So what I'd like to do is replicate this in Python. So the program's over here. Go ahead and double click. Control A to select all, Control C, and then let's go over to Python, do File, New Notebook, and then change the name right here. And what I want you to change that to is FV Simulate. FV Simulate. FV SIMULATE. FV Simulate, where the FV is capitalized. So let's go ahead and do that. And let's take a look at that program. Again, you're going to make this FV Simulate. So the first thing this program does, before it actually starts the program, it's going to import NumPy as NP. That's one of those packages that allows us to manipulate data and use arrays. And then I'm going to start a program. So you always start with def, and notice everything's indented from there. And the program is going to be called sim, has no parameters, and you always have to end the def line with a colon. And then I have a statement here: this sim program creates a Monte Carlo simulation of portfolio values. Then I put all the values using specifying variable names here. Let's set PV equal to 1,000, mean equal to 8%, vol equal to 20%, first payment equal to 5,000, payment growth equal to 2%, and T equal to 20 years. All right, so I have all those values in these variable names. The first thing I'm going to do is I want to calculate, in theory, what should the expected value be? Well, I just said FV no risk. In other words, ignoring the volatility. This is just the formula for the future value of a growth annuity. It's the formula for the future value of a growth annuity, so it's equal to the present value times 1 plus mean to the t plus the first payment, and so on. So you can find this anywhere on the web, the formula for the future value of a growth annuity. And then I go ahead and print the expected value equals, and I round that number with 2 decimal places. All right, so that should kick out that $245,000 number. Let's make sure that's right. That's that, I'm sorry, it's that 269,245 number. That's what it should kick out right there. All right, now we're gonna run the simulation. This is gonna get fun. I'm gonna first select a number of iterations, and I'm gonna do 1 million iterations. Why not, right? We're just using web resources from Google. So I'm gonna have 1 million random future values. The more you do, the more likely it's gonna converge upon the true value. And then I'm going to do a code from NP. Remember, NP is NumPy. NP has a function or an object called zeros. So sims, I'm going to set up a variable named sims equals np.zeros, and then iterations is 1 million. So here's what this is doing. This is telling Python to create an array of 1 million rows or 1 million items within an array, and just go ahead and plug in zeros there. What this is doing, again, if I go to my spreadsheet, it's really just reserving this space here for 1 million portfolio values. I'll fill it in later. All right, so let's move on. The next thing this program is going to do is we're going to set up some loops. The first loop is going to go for I in range 0 to iterations 1 million. So that's going to count the iterations of the simulation. It's just going to go from 0 to 999,099. So it's 0 to 1 million minus 1. Remember, the final number, it's everything below that number. But it starts with 0, so it's going to do this. It's going to set up a million numbers to be counted from 0 to 1 million minus 1. Then I'm going to set future value to go present value. So again, initially I have $1,000 in this portfolio, or $10,000 in this, $1,000 in this portfolio. So let me initially set the future value equal to that $1,000. Here's where all the action's happening. I want to create a loop, another loop within this loop. So this loop is just setting up each one of the iterations. You know, think of it as, again, as that spreadsheet area where the 1 million numbers are going to be stored. This one's actually calculating the future value in 20 years, 1 million times. So for j in range 1 to t plus 1, t is 20 years. So it's from 1 to 21 years, but it's always going to be 1 less than 21. So this is going to go, j is going to go from 1 to 20. That's going to be my year counter. I'm then going to create a random z, standard normal random z, normally distributed standard normal z. That's all those numbers, mostly between, say, -3 and +3 with a mean of 0. NumPy has a number, a standard normal random number generator called random.standard_normal. So I'm going to say random z is equal to np, that's NumPy, and then .random.standard normal. So it's going to generate a standard normal number for me. And then I'm going to say payment, figure out what the payment is. Payment equals first payment times 1 plus the payment growth to the j minus 1 power, because I don't want it to grow the first time, because the first payment is not going to be the payment times 1 plus g, it's just the payment. And then here we go. FV equals FV. Again, this is j is equal to 1 right now. FV equals FV times 1 plus the mean plus a random z times the vol plus payment. Notice the indent stops. So it's going to go back up to this j loop and set I equal to 2. It's going to get a new random number, get the payment in year 2, and say future value equals future value, which is the number before, times 1 plus the mean times a random vol. So this is going to be run 20 times. So effectively, back to my spreadsheet, that part of the code is going to run this each time it runs through the iteration. And since it's a part of a larger loop, it's going to run this 1 million times. All right, back to our program. Once it's done, I'm going to put, once it's run its course of the 20 years, it's going to put in sims I, the rounded number of future value. So back to the spreadsheet, what's this really doing, this piece of the code? It's putting the first random portfolio value, say here, but we're going to call that Sims. So that's going to be run 1 million times, and I'm going to wind up with 1 million simulated portfolio values. All right, now, how am I going to get some of the analytics out of this? I return my Sims here, end of the program. All right, I'm going to say Sims equals sim. Remember, the name of the program is sim. I'm going to print the average of the numbers in Sims. All right, Sims is going to be those 1 million numbers. I'm going to do np.mean. Remember, that is our NumPy. np.mean of Sims, 2 decimal places. So I'm going to get the average of the simulation, and also going to print the number of iteration, sims.size. So .size is going to tell me how many iterations there are. That's the number of rows in Sims. Now I'm going to calculate the 10% highest, the 10% lowest, and the probability of having, say, more than $400,000. So here I go. I'm going to do something called sort. I'm going to create a variable called sorted Sims, which is a new array of 1 million numbers, and it's just going to be a sort of Sims. So I'm going to sort those 1 million portfolio values from low to high. And then I'm going to calculate just return the 1,000 or the 100,000th number in that series. That's going to be the 100. That's going to be the 10% lowest. Again, there's 1 million numbers, and then I'm going to get the 900,000th number in that series. That'll be the 10% highest, right? 10% of 1 million is 100,000, so the lowest would be 100,000. Or the 10% lowest would be 100,000. The 10% highest is 900,000. And I just wrap them in this print statement. 10% smallest value is the 100,000th number in sorted Sims. And then I'm going to calculate the probability of exceeding a threshold. I'm going to set the threshold of $400,000. I'm going to use a NumPy object here. Probability equals np.sum. So it's going to sum the number of Sims greater than $400,000 divided by sims.size. So it's going to calculate, it's going to count how many Sims are greater, how many numbers within Sims are greater than 400,000, divide by 1 million. And then print the probability equals, and then comma probability, which is just this value here. And then just for fun, just to show off, I graph the distribution of the actual FVs. I import matplotlib pyplot as plt, and I say plt.histogram hist sims and with 25 bins. There's the results when you run this program. It gives you the expected value of 269,245, exactly what we're expecting. The average of the 1 million iterations is 269,331 after you run that. There are 1 million iterations. The 10% smallest is 119, 10% highest is 463. How'd that compare to our spreadsheet? Well, it's not going to be exactly equal to the spreadsheet because the spreadsheet only did 10,000 numbers, but it's pretty close. Spreadsheet said probability of more than 400,000 was 15%, and our probability here is 15.5%. Exactly what our spreadsheets showed. And then I just get this histogram. You can see there's a lot of numbers. Looks like goes upwards of 1.25 million and somewhere lower here, a couple 100,000. So that's the program. Those are the results. Results look just like our spreadsheet. But once you get something set up like this in Python, you no longer need to create spreadsheets, and you can verify the number of years and so on. Here's going to be your main assignment for this section. First thing you're going to do is go ahead and print the PDF off, do file print, save as PDF of what you just ran. Now I want you to create another notebook. We're going to call it FV Simulate 2. So go ahead and create another one, FV Simulate 2, and go ahead and copy that program that we just did and put it in there. But I want you to modify it now. I want you to add 2 additional parameters. Actually, it's 3 additional parameters. We'll change that to 3. 3 additional parameters. And those are initial salary, salary growth, and contribution percent. I want you to eliminate the parameters payment growth and first payment parameters. And I want you to eliminate the FV no risk calculation and print statement. So back here, just eliminate that code that does the FV no risk and the print. Okay? Now I want you to modify the program to use new parameters. And I want you to reset the parameters to these. Present value is 0, mean is 7%, vol is 18%, 40 years, so this might be your portfolio 40 years from now. Initial salary $60,000, salary growth 3%, contribution percent 15%, so you're going to contribute 15% of your salary to a portfolio. And threshold, let's make that 3.5 million. Let's change that to 3.5 million. Okay, so here's what it's going to look like in a spreadsheet, but then you're going to do the code. The spreadsheet's right here, but let me show you it over here. What this is doing is effectively, instead of doing payments, it's just calculating your salary. Your salary is going up by salary growth. So the salary 1 year from now is the 60,000 times 1 plus the growth. And then your portfolio, which starts at 0, gets a contribution equal to 15% of your salary. And that's how it's going to grow. So what we'd expect is $2.714 million. So when you rerun this program, you should get a number really close to that. And then I created this random walk model of this program, that it's 1 plus the mean plus norm S inverse rand times vol. And now every time I hit F9, I get a simulated portfolio value. I copied that 10,000 times over here and got the probability that it's greater than 3.5 million. I got the average, which is pretty close. I got the 10% smallest, 880,000, 10% largest, 5.3 million. What I want you to do is modify that program, put it in that new notebook, FV Simulate 2. When you run it, and I want you to run it with these parameters in it, right? Change those right in the program. And then you should be getting numbers pretty close to these values here, except your sim average is going to be really close to the expected value. So that's it. That is your Python introduction. When you're done this, remember this assignment is all individual. Each student is to work independently to complete these assignments. Each student is to upload their own notebooks. It is an academic integrity violation to share notebooks or files or PDFs. What you're going to wind up uploading in Canvas for this assignment is from the first part of the video's CAPM notebook, PV annuity notebook, then grades notebook, that time series notebook from the second lecture, the Yahoo Finance notebook from the third lecture, and then from this one you're going to do FV Simulate and FV Simulate 2. That's that program you're going to run. If you can't get it running, that's okay. Just do your best. I'll see in the solution whether it actually ran and how close you were. Here are some sample exam questions on Python. What is a Python package or library? Give an example. What is a Python notebook? Name several syntax differences between Python and VBA. What is the array base value in a VBA and or Python array? Let's just make that and Python array. So what is the base? Are indents meaningful in VBA or Python? Is letter case meaning upper or lower? Is that meaningful in VBA or Python? What is the equivalent Python command to VBA's function command? What is a Python data frame? What value will this code run? So if you want to try to answer this without actually running it, but if you had for I in range 1, 100, indented x equals plus I, and then x, what do you think it will return? What does this code do? X equals np.0 is 1000. What does this code do? X equals np.random.standard normal. All right, so it gives you some idea. I don't make the Python too difficult on the exam. I'll just add maybe a question or two for a small percentage of the exam. But I just want to get the impression that you went through this, you reviewed some of the differences in VBA versus Python, and I'll be adding some Python questions to future assignments, but not the final exam, most likely. But we'll talk about that later. All right, so that is Python.